Hello everyone. Welcome to the webinar of design and development of go-kart chases. Welcome our speaker, Mr. Shivam Patel. Shivam Patel, you can start now.
Okay. Good evening, everyone. Hope you all are doing great. So, we'll be discussing about the design and development of go-kart chassis. And okay, let's start. So, good evening, everyone. We are familiar with the vehicle called go-kart, and we will be discussing the design and development of the go-kart chassis. So, the go-kart is basically a Formula 5 category vehicle, and we can say it is the pioneer or the entry-level motorsport vehicle to enter in the Formula world. So, we'll be discussing about the chassis and the development of the chassis, how we will select the material, what are the aspects for building a chassis for go-kart, what are the points which should be we should keep in mind during the production or the fabrication or the designing of the chassis. So let's start with this. So the topics which we are going to cover in this webinar is the basic about the go-karts, the design selection, the material selection, and we will have a brief on system of designing of the chassis on system as well, and we'll be doing the analysis at the end of the webinar. So you'll get a brief idea upon how the forces acts on a vehicle chassis, or what are the forces which are acting on it, and how the vehicle chassis which we have developed reacts upon the forces. So basically there's 3, 4 or 5 types of vehicles. There are similar category vehicles, these go-karts. One you can see on the left side corner is an off-road go-kart, which have a suspension system in it. Otherwise, there is no suspension used in go-karts. Yeah. Is my audio clear now? Hello, Naveen sir, is it clearly now?
Yes, sir.
Okay. So on the left side corner, we can see it is an off-road go-kart, which is having a suspension system. Many people may confuse it with a buggy or an ATV, but it is not so. This is a proper off-roading go-kart. Otherwise, the go-kart doesn't have any suspension system. So the chassis which we are going to develop, or which should be developed, is made to be accordingly that it should counter the forces which are acting on the chassis, which should act as a suspension system also for our go-kart. On the right side, you can see is a toy kart, majorly 8 or below 8 year children can use this. It is a very low speed vehicle.
Shivam, you are not audible. Hello, Shivam.
Hello.
Yes, you are audible.
Okay, I guess there may be something issue with this, but my system is working properly. I guess network issue or something. I don't know. I'm sorry for that.
Okay, okay. Okay, now
Yeah.
you can continue.
So we have missed something in this. Well, what was the last thing which you heard?
Toy cart.
Toy cart. So I guess you have missed so much things. Okay, no worry. I will explain other things also. So after toy cart, we can see which is a Formula cart on the center. It is a proper Formula 5 go kart, which is a Rotex kart. We can say a two-stroke engine is used in this, and each and every Formula 5 event or a national championship, we can say international championship, we can say this particular go kart is used. It is having a two-stroke engine, and the top speed goes up to 150 kilometers per hour. So this is a proper Formula 5 go-kart. Other two go-karts which you can see at the bottom of this page are recreational or used for recreational purpose or the students through the student championships. It is a four-stroke engine. This go-kart is having a four-stroke engine, while the other one is the electric kart. They all cards have similar thing, which is the chassis, which is a similar chassis. All the substitute components are different from it. Whether we use a four-stroke engine, whether we use an electric motor for it, whether we used a two-stroke engine also in this, we can use a 50cc to around 600cc engine can also be swapped in this. Many people around the world have used this kind of engine in the same chassis. So we can understand how stiff or like how durable this chassis should be made. So next, going for the material for this chassis, how we will decide the material, what are the materials available in the market, or on what basis should we, what we say, select the materials for this go-kart which are durable for our vehicle, which may, what we say, comply with our norms and all. So we'll go for the material selection. So basically, this is the criteria on which we go for the material selection, and we will understand what are the necessary things on the basis of which we should select our material for our go-kart. As we talked earlier, it has no suspension system, so we can understand that there are many loads acting upon the chassis, which directly passes through the vehicle frame and vehicle chassis, and which is the only main thing which consists of all the components of the vehicle. So the yield strength of the material should be high, and the density of the material should be low. I guess there's a printing mistake by me in here. It should be density of the material should be low. Why should the density of material should be low? Because if the density of material is high, then the material weight will be more, and the yield strength should be high. Because when we apply forces to the material, they transmit from one end of a material to other end of a material. So if the material is having a low yield strength, it will fracture or rupture. So yield strength is necessary for a material. While as counter to it, the density should be low, because if the density is high, the material will weight more. And we do not want our vehicle to weigh more. We want our material to be light, but we need the material to be stiff as well, so that it can absorb all the load or all the forces acting on it. Next is the availability of the cross section of a material. Generally, go-kart are made by two sections. Whether you can use a cross section, which is square section, or else a cylindrical pipe is used, tubular material is used. Majorly, when we will see, we will come across the tubular material, because it is one of the best kind of sections we can use for it. Whereas somewhere when tubular material is not available, or they are only just made for the purpose of fun or recreation activities, they use somewhere is square section. But in formula or in the events, or what we say, when we build a proper go-kart, tubular material is only recommended. We will see next which tubular material should be selected or not. Rather than tubular material, you can also use square section material, which is not a big deal, but the strength or the criteria which we selected for this go-kart will not match. Next is the weldability. The weldability should be proper, because there are joints in the chassis which act as the counterparts for the suspension system, as well as the stability of a vehicle are also depend upon these joints, that where we keep these joints. We cannot abruptly keep a member, like we are placing a member on a material in the front, we are placing a member in a back. It is not so. These each and every member where we weld possesses the tendency for the stability of the vehicle, as well as the strength of the vehicle. The carbon percentage should be less than 0.8%. If the carbon percentage goes above this, we can use, but then the material will start becoming brittle. During the impact, the material can break. The carbon percentage, adding carbon to the material gives strength, and we need strength, but it should not be more than this, because adding more carbon will make this material brittle. During the welding, due to high amount of heat produced in it, the joints may become brittle. So when we have an impact on this vehicle, or there's more vibration produced during the running of the vehicle, there may appear cracks on the material where the welding is done. So the carbon percentage should be, majorly when we use this material, they are around 0.1% to 0.3 or 0.4%, not more than that. But this is the maximum range given in the rule books, or the, what we say, major manufacturers which use this criteria for the selection of their material, which are known manufacturers. So we use this criteria for the selection of our material. Last is the costing of material. There are ample of material which are available in the market with the similar cost, similar material grade, similar specialities in this, but still we verify these materials, and still we bifurcate these materials on basis of the cost. See, it happens sometimes that we are making a vehicle for an event. Then there is possibility.
ಇವತ್ತು ಪ್ರಾಜೆಕ್ಟ್ ಎಕ್ಸಾಮ್ ಇತ್ತಾ?
Okay, so we can continue. We were talking about the costing of the material. The cost of the material varies upon the marketplace, as well as the state where, or the place which we are buying this material, and the material grade itself. There are so many grades available for the similar piece, which we'll see in the next slide. So costing is the main, what we say, it plays a great amount of role in the selection of the material also. Sometimes we can get a cheaper material, sometimes we can get a costly material depending upon our need. See, as I was saying that when we are making a formula car or in car formula kart or kart which is going to be used in an event, there are some constraints with us. The material should be effective, but the cost should be low. Sometimes we get the effective material, but the cost is high. So we need to optimize both the things. So based on that, we have selected some material, 3 or 4 materials which are cost effective also, and which we get the what we say our desired properties also. The desired properties which we told, which we see that the yield strength is high or the density of material is low, the weight, the availability of the material, the machinability of the material. During sometimes it happens that when we are using a 4130 tube, we can only use TIG welding on it. We cannot truly use arc welding, or it may burn, or the material will melt. But whereas compared to it, if we are using AISI 1018, the same thickness of the material and the same what we say the same amount of material, still we can use arc welding on it. The material will not burn because there are some amount of changes of the properties in the yield strength, in their ultimate strength, the density. The density of 4130 is less, whereas the density of 1018 is more. So being a dense material, it will not melt easily during the welding. So some material needs special welding techniques, whereas some material which we can use can be used by regular welding techniques such as arc welding or MIG welding. When we go for aluminium material, the aluminium material has the lowest weight, means the weight of the aluminium is lowest in this category. But the machinability is not there, or weldability is not very high in it. We need to use special welding techniques like aluminium brazing welding or what we say TIG welding.
Excuse me, sir, we are unable to hear you.
Shivam, you are not audible.
Sir, my mic is on.
Yeah, you are audible.
You are audible now, sir.
Okay. Just a minute. Yeah, should we continue? Hello.
Yes, Shivam, you are audible.
Yes. Okay, so we were discussing about the material. Sir, can I get? I don't know where is the issue, but can you tell me from where we stopped?
Welding issues in aluminum.
Okay, welding issues in aluminum. So we were near about welding. There are welding issues in aluminum. We need to use special techniques like aluminum MIG welding, which cost more than any of these welding processes. Even aluminum is costly. So the material selection criteria should be according to our design selection or according to our need. If we are trying to make a lightweight vehicle or vehicle with low engine category or less power, then we can go for aluminum. If we are going for higher CC or higher category, the weight of the component is more. like the engine weighs more, the other component, like if you are using an electric motor for it, if you are using battery for it, electric go-kart, so the weight of the component is more. So based on that, aluminum sections are to be added in what we say, the amount of aluminum sections which we add in the chassis becomes more. So welding of this chassis, the joints which we made, so the number of joints increases. Other than that, we can use steel in place of aluminum. Less members, same strength, less welding, same stiffness we will get for it. I guess we will, if we use 4130 in case of aluminum, the weight difference may occur drastically. Like I'll show you the chassis which I tried making in aluminum as well and 4130 steel as well. The difference comes around 10 kgs. So it is very much big difference in amount if we consider for the chassis like this in weight. But the strength which we get in 4130 is nearly equivalent to the aluminum. So these are some points which we discussed right now. The main intention behind selecting the various materials and deciding one of the material for the chassis, which gives best results considering the driver safety and real-time load-bearing capacity. As we discussed, the load-bearing capacity of our chassis should be good, whereas the machinability or the weldability should be good also. See, what are the types of load which do the chassis undergoes various type of force during the locomotion, and it has to stay without yielding also. It should be stiff. It should absorb the vibrations also. As we said that there are no suspension systems used in this go-kart, so all the vibrations which occur are transmitted to the chassis itself. High resistance to the temperatures during the welding. The high temperature rises means the amount of temperature which rises. The material should resist the temperature also. It should not melt. The chassis should be flexible enough to work as a suspension system, but it should be stiff enough not to break. See, this is the term which we were discussing. Adding more members or adding inappropriate members to the chassis, which will deduct the flex from the chassis. We don't want torsion in the chassis, but we need flex in the chassis. The torsional movement of the chassis should be less, but it should not be that much less that it counters our flex. So the flex should be present in the chassis. A little amount of flex is okay, as it works as a suspension for us. But it should be stiff enough that it should not break during the torsional forces when the torsional forces are acting on the chassis. When the go-kart is running on the track, there are left and right turns. The vehicle goes on the curbs. The vehicle goes in the. Sometimes there are banking on the tracks. A little bit of banking is given. So all these forces occur on the chassis, directly transmitted to the chassis. The next thing is the driver safety also. When we use an aluminum material or a soft material, if the vehicle goes for an impact, it will crumple. So the driver safety is also important as well. If we are using a very high strength, high stiffness material, still it is an issue for us. Why? Because when we use a much more harder or much more stiff material, then the chassis, during the impact, it won't transfer the load from one point to another point. The load will be transferred directly to the driver because it is an independent component sitting on if we consider the driver as an independent component who is attached with the chassis, all the force during the front impact will travel till the back, but the chassis will not absorb the force. It will directly be transmitted to the driver. As it is a loose component, there are no seat belts, there are no clamps on the drivers. So the driver is an independent quantity or independent entity on a vehicle. So their force will be directly transmitted to the driver, and the driver will have major injuries. So deciding a material, deciding a design, which kind of design we need to make will depend upon us, so that we give maximum protection to the driver as well as we get the maximum efficiency from that design. Because if something happens to the driver, our whole event or our whole championship race will come to an end. So driver safety is as much as important as we build our vehicle for our good performance. So if we build a moderate chassis, considering both the things in it, the available performance and the driver safety, we will what we say design and produce a good vehicle. So generally a tubular space frame chassis or a ladder frame chassis is used. No monocoque chassis are material or made for this because of its manufacturing cost. And working on tubular pipes is more simpler than working on a monocoque chassis. So now we'll go for the next. These are the materials which have been decided by us or which are generally used by the known manufacturers of this industry. AISI 1018, AISI 1020, AISI 4130. Aluminium, the steel yield strength and ultimate strength is not mentioned in here. Is the reason because there are multiple multiple grades available in this also. Aluminium 6061, we get T1, we get T2, we get T6, up till T6 we can get. Recently I discovered at least T7 also, but they are having different properties for that. The more T1 to T6 you go, the more stiffness, the more strength you get, the more hardness you get. Another one material is, I guess, which is 7075, which is an aluminum alloy. All these are alloys. It is a soft kind of material, but it has stiffness which is good for that material is low in weight, and we can use it to make shaft also. The rear shaft of the major performance vehicle is made from either aluminum 6061 or 7075. Now 1018. So 1018 and difference between 1018 1020 is not much. They are similar kind of components, but the major difference comes as 4130, which is called as chromoly. We know this material as the name of chromoly. Now chromoly, the density of chromoly is low, but the stiffness and yield strength of material is very high. So majorly when we see the national karting chase, national go-kart chases or international championship chases, the Rotex which we use, the Rotex or the KNN, they majorly use this material, 4130, just because it has more performance qualities than 1018 or 1020. But when we go to student championships, student majorly use 1018 or 1020 or C45 because the cost of this material is half of the cost of 4130. If we are getting 4130 at 450 rupees per meter or price, we will get 1018 at half of this cost or just more than half. So accessing this material is very easy. Availability of material, when we say, then 4130 is available at some dealers only, whereas AISI 1018 and 1020 are available in ample of spaces. When we go to our local market or when we search for this material in our local markets, we'll generally get 1018 pipes of 1 inch cross section. But when we are finding 4130, we need to order it from some other state, or we need to find a particular vendor for this 4130 material. Same is with the aluminum also. Aluminum is available everywhere, but particular grade for aluminum, which is 6061, or the particular grade which is 7075 alloy, which is not available everywhere. So many people decide to use 1018 or 1020. This is the sample chassis. Now, sample chassis is this is the chassis which is used in all Rotex cards or all Tony cards or K&N cards which are majorly used for championships, national championships. Similar chassis. There may be little difference in this, but these are similar chassis made from same material, which is 4130 or 1018. Now there are two cross sections used in this thing. One is 1 inch and one is 1.25 inch. If you want, yes. Hello. Yeah. There are two cross sections available in this chassis or this material, which is 1 inch and one is 1.25 inch. Generally, these kind of chassis are made from 1.25 inch material. The properties of this we get is high stiffness but low weight. The weight of this vehicle or these chassis which we are seeing is majorly around 10 kgs, not more than that. But when we use 1018, it is 4130, 1018, the weight may increase. It can go up to around 13 kgs or 14 kgs maybe for this similar chassis, just because of the density of the material, whereas 4130 is less dense. Now, the design which we are seeing in the screen is called as bottleneck design. Now, what is the need for this kind of design particularly? You may have seen many other designs for this frame, many other cross-sectional used for this, many other members included in this chassis. But for this particular chassis, it is not needed. We can use this particular chassis for electric vehicle also. We can use for IC engines also. We can use a 50cc engine also in this. And we can use a 200cc engine also in this particular chassis without adding any other cross member or any other extra members which we need. Majorly what people do is they create a design, then they do an analysis on it. So wherever they see that it is a red part or wherever the danger zone increases, they add a member to it. But what we can do is, without adding a member, we can shift some member or we can adjust some other member in this so that it can counter the same thing without adding more material. So this bottleneck chassis and the properties which we get with this is the crumple zone in between. Just a minute. See this part which you can see. This acts as a crumple zone. This center portion, if we add a pipe directly to here, it will not act as a crumple zone. But the bend in here, these two bends in here, they act as a crumple zone. When the force is applied from the frontal direction, these 2 points will crumple and the force will be transmitted to the chassis, and half of the force will be absorbed by this front member only. If we add any kind of members in this we will lose this property. So bottleneck design is important for these kind of go-karts, or bottleneck design is necessary to provide for these kind of go-karts, just to provide for the driver safety and the same properties which we get from the square design also. See, the stiffness and the hardness will be same. There will be no changes because there is a triangulation provided in here. We will get the stiffness, we will get the torsional flex, a little bit of flex, but no major torsional moment. But we will get the safety on here. The front impact will occur and these 2 points will crumple. This is where our driver gets a safety. This point will crumple into it, the driver's leg will go in front. If we do not provide this crumple zone in here, during an impact, all the force will be directly transmitted from the chassis to the driver and the driver's legs will be fractured, or the steering may rupture his rib cages, because the directly impact of the steering wheel goes on the chest of the driver. So ergonomics also plays a main role in this. If the driver's safety, we'll go for the next and we'll see how the driver ergonomics acts in this. So this is the sample chases. The sample chases which we have made in it for our design and stimulation for fit. You can see it is a similar chases with this, but adding a roll hook which will increase more safety to it, because during sometimes when the cart is running at high speeds, during the bump of two vehicles, sometimes the front wheel of the rear vehicle goes on the rear wheel of the front vehicle, and the cart may flip. So if we do not provide a roll hook, the driver may cause the neck injury, or the cart may flip upon the driver. So the roll hook is provided. It is the same bottleneck design which I showed you here, but as we cannot copy the same design from any manufacturer, we created this sample design for us, and we will be doing the analysis of this portion. Now you can see there are two members in this. The bottleneck design has been given. The rear structure is made in such a way that we can install an electric motor on it, or else we can install an engine on it.
Shivam, you are not audible.
Hello.
Yes, you are audible.
Okay. So we were talking about these chases, the sample chases and the difference between our chases. Hello.
Yes,
Hello.
Shivam.
Shivam, you can start.
Hello.
Yes, you are audible.
Yeah, am I
Shivam.
audible, guys?
Continue.
Yeah. Okay, so we were discussing about this vehicle and why this kind of design has been made, and what are the pros and cons of this design. Before that, we'll talk about the center of gravity. Hello. Sir, I guess there's an issue with the system. The mic automatically switches off. That's the reason that in between the mic is switching off. So I'll make sure it doesn't happen now.
Okay, I will check.
Yeah. So the center of gravity of this system, the CG of this vehicle directly comes under the driver's seat. So we need to make sure that the driver position in such a way that the vehicle becomes stable. Generally, during the go-karts, the weight distribution is done around 40 to 60%. Like 60% is the rear weight, 40% is the front weight. The 40% considers as the driver's weight, half of the driver's weight, and the legs, the weight of the front components. But the rear component majorly comes as battery, motor, engine, the fuel tank also, or sometimes when we add a radiator or a cooling system for it, generally comes behind the driver, because the rear wheels are the one which are getting the main power. So we need traction for the rear wheel. So weight distribution is generally done like this, that 40% should be the front weight and 60% should be the rear weight. The motor is just above the shaft, which is a rotating component, and the shaft is also a rotating component. The engine is placed in this place also. The battery is a stable component and a static component. The battery doesn't move. So it is fixed just behind the driver. And during the turning or the yaw movement, when it comes for the yaw movement of the vehicle, these things should be stable. Now during the impact, if the driver is sitting more to the front side of the vehicle, why this design is selected, I'm telling you that if the driver is sitting more like 50, we have distributed this thing as a 60-40. But if the driver is sitting upright position, like more towards the front end, then during the impact, this steering system will directly hit to the driver and the driver may have injuries. So this system has been, this chassis design has been appropriately designed, and we have crash tested this chassis as well. So what I'll show you the analysis of it, and we'll see how it works on this chassis.
Excuse me.
Yes.
May I know the measurements that you have taken for the understeering as it is a oversteering, as it is a rear wheel drive vehicle, and the elongation of swing arms in the front section that are connected to the steering seems to be a bit short in this chassis design.
Yeah. Can you repeat, please?
The steering system that is connected to the front wheel, as it is a rear wheel drive, it shows more oversteering. So how we are going to counter it, and how we are going to control it?
Okay. So see, this design which is created, the measurements, just a minute, I need to check for my design report because I directly take it from the design. I'll give you the measurements for it, but just complete this, and at the end we'll discuss about it. Till then, I can just take the measurement for it. Okay. Yeah. Hello.
Yes.
Yeah. Can we start the design? The analysis of the design.
Okay. Hello. My screen
Yes.
is visible?
Yes.
So, 1 minute. There is an issue with my laptop.
See, this is the following chassis which we are using as a
Hello. Am I audible?
yes. Yes.
Actually, my screen just got
Yeah,
out.
your screen is visible,
I'm
sort
not
of.
able
You
to
can.
see.
No, your screen is visible
But
to
my
us.
laptop screen is not visible to me. Actually,
Okay.
there is a
You can go on
in
with
my
the
area.
and no, you can
So-
go with the analysis of this chassis.
Actually, I'm not able to see anything in my laptop. My just screen got off. Sure. Are you understanding?
Yeah, just a minute.
My laptop screen is not. I think there is a technical issue with my laptop. Hello.
Yeah,
Shyam?
Saurabh, are you ready with it?
Yes, I'm ready.
Yeah, you can present your screen.
Hello, my screen is visible.
Yeah. Yes, yes, your screen is visible.
Just a moment. So everyone can see this chassis. So
Yes, yes.
So at the first point, we have to import the chassis from our design in the ANSYS. Then we have to select the in geometry. There is a we have to select the material. Just a moment. So at the start, we have to go through the engineering data. In which we have to select the material and we have to return all the properties which were required for the analysis purpose, like yield strength, Poisson ratio, Young modulus, and etc. etc. You can see here there is a tensile strength of the material, and there is a ultimate strength, and the Poisson ratio, and the Young modulus. This four is required for the analysis purpose for any material. You can get these values from the Google itself. After that, we have to go through the in here.
Excuse me, sir. Hello, hi Saurabh. Your voice is not audible.
I think there is a system issue. My mic automatically turn out. So you can, Shyam, can you tell me which point I'm last, which is audible?
Yes,
We were importing the values from, we were importing the values in this and importing the chases to the bench work.
Okay. So after that, we have to import the chassis in the workbench, and after that, we can go through the workbench, and we have to select the setup and the module part. In setup and module, we have to solve the problem. So all the chassis is imported. Then we have to select the material in the geometry section in material assignment. So here we have selected 101M, which we have put in the chassis. This is basic material for go-kart in student chapter. Then we have to connect with the all the for the analysis. We have to calculate the three things, which is fixed support, the force location, and the force value. So for the fixed support, we have selected the 4 point of the tire.
Excuse me, sir.
What?
Screen share is in the PPT. Analysis is not being screen. Analysis is not being screen shared.
It's also screen shared. You have to.
The screen is shared. No, the screen is shared. The screen is visible. Saurabh, you can continue.
After the importing the chassis, we have to go through the material selection in the chassis itself. Then we have to go through.
Saurabh, your mic is mute.
This is a very fine mesh. After the importing the chassis, we have to select the material from the geometry itself in the material sections. After that, we have to go through the mesh and create the mesh and selecting the element size.
Saurabh, your mic.
Now I'm audible.
Excuse me,
Yes, you
sir.
can continue.
Yes, sir.
Your material
the
selection
fixed
was not visible. Actually, we just want to know what material have you used for making this chassis?
1018.
Okay, thank you.
ASA 1018. After material selection, we have to go through the mesh, select the mesh and the sizing of the chassis, and run the mesh program. After that, we have to go through the selection of three things, which is the fixed support, force location, and the force value.
Saurabh, your mic.
I think there is an issue. Somebody talks and the mic automatically goes off.
It was same issue sometime for me, but now it is fixed.
Okay. So for the fixed support, we have selected the 4 mounting points of the go-kart. Here are the 2 spindle location for the front and the 2 spindle tire rear mounting points. Okay. After that, we have to put the force on the chassis. So we are selecting this for the front impact. So we are giving the force on the front member on the inward direction. You can see the direction. Here is the Z direction. In that, we have to manually input the value. It's a 3000 Newton value according to our calculation for this chassis. And the 3000 value, and we have to run the program and import the solution. And in the insert section from the stress, we have to go the maximum principal stress, deformation, and in stress tool there is a factor of safety chart. So we have to import that. And after that, we have to solve all the program, and we can see that results.
Hello, sir.
Yeah,
Not
Saurabh, your voice is not audible to us.
1 minute. Just
Can
a
you
minute.
please restore it? Yeah.
I'm restoring the software.
Okay, sir.
So here we can see the
Hi. Hello, Saurabh. You're not audible to us.
so there is a problem with
Saurabh, can you do one thing? Can
system.
you check like who has muted you so that we will kick out the person from the meeting?
Sir, I can't find that.
We won't be able to find it. No? Okay.
Only admin can find it.
So once you are getting muted again, na, just let us know. We will kick out that person. Just let us know as soon as possible. Once you identify that
Okay,
person.
sir.
Okay.
Yes. Software crash.
Saurabh, can you please restore your software and show us the results? We are waiting for it.
Yes, I am restoring the software. Wait a second.
Screen is not
Now you
visible.
can see the chassis.
Now it is visible.
Hello, hi Saurabh. Can you do
Yes,
one
you
thing?
can continue with.
Can you minimize the use of
Saurabh, you can
the
continue.
space bar?
Yes, sir.
Screen is not visible.
Hello. I think there is a software issue. I can share the analysis on the screenshots.
Pardon? What are you doing?
Actually, the software is getting crashed. So I'm showing the results on the screenshot.
Oh, yes, yes. Then you can send a screenshot so that we can see what is there.
So the results are with me, with the screenshots are with me, but
Oh, yes.
yeah, sir, I'm sharing the screen right now.
Yeah.
Sure. You can continue with him.
So we have the results, but when we see it in the actual software, we get the exact amount of data, how much the amount of deformation has been produced on this chassis, or which factors are more affecting, or which are the points, which are the hard points where the load has affected the most, has been clarified with the on-screen data, so aspecting the on-screen data as well. But till then, we can use this as a knowledge. See, this is the data for the front impact. Now, these front impacts and the impact, they come in Okay, so this is around 2 of deformation. The exact amount of data will get it from the software as well. The force which was applied on it was around 3000 Newton. We can see the front impact data for it, the side impact data for it. See, all the stress has been distributed among the chassis. There is no point where it goes for the maximum, which shows as red color. So we are in the blue range or mid blue range, or somewhere it is green. The green which indicates where are the welded points. The welding joints we can see which are minute green color, which shows that there is some load affecting on it. But when we weld on the same point for multiple times, it becomes brittle. And from there, the parts tends to break. We can see the diagonal or the torsional data. See, this is the amount of flex we need in our chassis. But if we do not provide this flex, the frame will bend. And once the frame will bend, it will not restore on its own, or it will not restore to its original value. Then the vehicle will be tilted. So we need this amount of flex in it. But we do not need more amount of flex, or else it will produce a torsional deformation in our chassis. Saurabh, has the issue resolved in our software?
No.
How long is the rear impact? See, after these results, we can see that the chassis is safe for the driver as well as the component as well. These deformations are very little amount of deformations are occurring from all the sides, which means that the design which has been created in this is an adaptive design, which is good for the component as well as the driver, as well as the stability of the vehicle is maintained in this.
Sir, you are muted again.
Sir, yeah, sorry for it. Saurabh, just a minute. Is the issue resolvable? Yeah, the velocity was taken as 60 kilometers per hour. Or I guess 40 to 60 kilometers in between it was taken. And this is the final rear impact for it. Now the driver ergonomics for it. As you can see, there's plenty of room for driver in it as well as the components of it. And all the measurements which are taken in this vehicle are kept according to the safety of the driver as well as the distance between each and component where the driver or these components may not touch each other has been effectively created in this. This is the driver ergonomics. Each and every vehicle has to be prepared according to this ergonomics, but due to some constraint, these are compromised. Majorly in student formula events or student cards, we can see that these ergonomics are compromised or are being intentionally compromised by students. So just that they can get more part for their engine or more part for their components rather than the driver. But in such cases, during the impacts, the drivers are injured. So this is an ideal driver ergonomics which should be taken in care of. Rather than we can say an SAE 95 rule is also been applied for this, which is 95th percentile rule, in which there are some angles given as per according to the rules of FMSCI or the SAE, which rules may comply with this. So these are the angles given for the driver, which are best considered for a driver safety as well as the vehicle ergonomics or the driver's ergonomics, in which possible way that the driver cannot the driver can perform his best. So we can see that the knee angle, the torso angle, or the elbow angle. When we change these angles, or else when we do not produce our vehicle according to these angles, maybe there's possibility that the knee angle will become less, so that the height of knee will increase or it may touch the steering wheel. When the elbow angle is decreased, the driver is more front biased to the steering wheel. So during the impact, the steering wheel may impact the driver. This distance is enough for a driver to handle the impact or handle the intensity of the impact. The foot angle. If the foot angle is more rather than the foot angle is more than the given angle, then he or she may not properly apply the brakes or not properly able to apply the throttle. If the foot angle is less, then more fatigue will be created in the ankle of a driver, and it may possible that before time of the race or before the endurance finishes, he or she may get fatigue or he or she may get tired or pain may be occurred in the ankle of a driver.
Okay.
Same thing happens with the elbow also. If the elbow is more restrained towards the chest, the driver may feel discomfort during the turning of the vehicle. The body, when we see if the vehicle turns left or right, the body leans in the opposite direction. So due to inertia, the body goes outside. So many drivers try to prevent this by leaning inside while turning in the corners. So if we are turning to the right side, the drivers sometimes try to lean inside the corner so that they can prevent the load transferring from the vehicle to go outside it, and they can prevent the vehicle from skidding. Sometimes if more weight transfer is he or she may not be able to counter these forces. So sometimes during side impact or during front impact, the neck of the driver, even wearing a neck restraint, can be injured. So driver ergonomics is more necessary for the safety of driver in this vehicle. So we need to produce our vehicle chassis in such a way that we give driver a proper amount of room, and the components are also be packaged in this whole chassis. So when we see this kind of frame or this kind of chassis, the driver is getting enough space for it, as well as the components are also getting enough space for them. In this, when we see a rear, the stand is given for it. The mount is for the motor itself, and this mount can also be used for engine as well. So both the things can be placed in a similar way or a single mount, and there are no other changes to be made for the engine or to replace the motor for it. So the driver compartment becomes independent and the rear compartment becomes independent. Yeah, so this was it for the brief information for vehicle chassis and vehicle dynamics. We can go in very deep if we want for this. Each and aspects can be discussed, or each and every aspect, each and every part of the vehicle can be discussed in such a way in deep. But this was a brief information about it from my side. And there was a doubt from a student about the steering length or the tie rod length for this angle. The length of tie rod from end to end is 930 mm, which is divided into two, and around 460 mm is the single length of single tie rod, which is used in an Ackermann geometry. During turning, see the the camber caster in the toe also affects in the turning. So during the turning, if we can adjust the toe and we can adjust the steering geometry, or the handling of the vehicle can be adjusted rather than adjusting the steering geometry. So that's all from my side.
So understeering, oversteering concept has not been cleared by your side, sir, for this chassis, particular chassis.
Sir, you are not audible.
Speak English, please.
Hello. Hello. Yeah, sorry, dear, you were asking something. I lost my connectivity.
Sir, I just want to know that understeering and oversteering, how we are overcoming that on this particular chassis. There was no information given about that.
Okay. So the understeer and oversteer was countered by adjusting the tie rods itself. There was no other way we can adjust these things. Once the C clamps are fixed, you can adjust the understeer as well as the oversteer with the help of your tie rod settings. If you want your vehicle, if your vehicle is understeering, then you need to keep your toe a little bit more than the ideal value. Okay. So toe, you should not you should not do toe out majorly, but a little bit of toe out will counter this thing. See, the Ackermann percentage in this is 59.64 degrees according to my design, and the inside angle is 40 degrees, 40.2 degrees.
And sir, for yaw angle, how we are controlling the yaw angles means as the rear part is very far out from the front end, and on turning the yaw angles will be affected. So how we are countering that?
For that, we have to
See,
go
the
through the tie rod settings and the spindle settings. There is a two settings in the spindle, which there is a two holes in the each spindle, and we have to select the spindle, and according to that we have to adjust the tie rod and the characteristic of the go-kart.
Okay, thank you, sir.
See, this steering is adjusted.
Say the parallel geometry.
See, your track width. See, keeping in mind the track width of the front wheel and the what we say is the wheelbase of your vehicle. The steering geometry is always keeping in mind these two things. So the yaw angle which is created when you measure it with a triangulation from two spindles to your center of the rear axis, you will get the exact amount of steering angle which you want. So it doesn't matter if the rear end is long or rear end is short from the driver or from the steering. Once you measure the triangulation of your steering system, the geometry will automatically be calculated in that.
Okay, sir. No explanation was given on this process, so that's why I asked. Thank you so much, sir, for your information.
Yeah. Okay.
So thank you everyone for watching the webinar. I hope you like the session. Are we okay? Are we completed, Saurav and Shivam? Are we completed? Okay. So you will be getting the recording of the sessions through a mail.
Hello, sir. Hello.
Yes.
Hello.
Yes. Yes.
Sir, I have one doubt related.
Hello. Am I audible?
Hello. Am I audible? Oh?
Yes. Yes. You are. Over to you, Shivam. You are.
Hello. Sir, I have one doubt related with the ANSYS portion. Hello. Hello.
Shivam, are you here? Shivam, yes, Saurabh.
Yes, sir. I'm here.
Yeah, can you take the question? Can you take the question?
Okay.
Hello.
Yeah.
Hello, sir. In ANSYS, for validating the result, what we can do? Hello.
We should keep the factor of safety above 1.6. So in the student chapter, we have considered the factor of safety percentage is the 1.6. So while manufacturing the factor of safety come around 1.2, 1.3 according to the student standards.
When we presented this question was actually when we presented this question was asked how we have validated the ANSYS results. Hello.
Hello.
Hello. Yes.
Can you repeat the question?
They have asked us that how we have the ANSYS result.
Your audio is not clear.
Hello. Now I am audible. Hello.
Yes.
Hello, sir. Actually, they are asked how you have validated ANSYS result.
We have shown the chassis. We have crash tested it, and the result is accurate up to 95% for the front impact test.
But how we can say that? On what basis we can say that the results are 95% accurate?
It depends on the production quality of your team or your team. So if the welding is not good or the material quality is not up to the mark as put in the results, in ANSYS we have to put the all. If you are using the ANSYS value is 500 megapascal as a yield strength, but your material is having only 350, so the results may vary in practical scenario and the simulation scenario. So you have to consider that you have to material from the testing agencies, the material is up to the mark or not, and according to that you have to do the analysis for it.
Okay, sir. Okay. Thank you. Thank you, sir.
See, it happens sometimes that when we purchase a material from the vendor, they give us a certificate, but we do not know that the certificate is legit or not. So this is the reason we need to go to a laboratory and get our material tested. Because many a times it has happened that students or people buy material of some following grade like XYZ, like following we say 1018. But even in 1018, there are multiple grades. So we do not know which grade material are we getting from them. They are just saying that 1018 is this is the material 1018 with the specification and this is the price, you can take it. So we generally get the values from Google that the properties of 1018 is this, and we buy the material from the vendor. But it has happened that the material with the same specification bought from the vendor and the values from the Google were different after the testing. So when we test the material in certain laboratory, they check the values of it, and whatever the values we get are the legit values. So it happens sometimes that we need to check properly from the vendor itself. Sometimes vendor produces a certificate for all the material same. They just provide a material and they'll provide you with the certification that yes, this is the properties of the material. But it may happen that this certification is for the different material and they have provided you with the different material just for the cost cutting. It has happened to few people in the market. So we need to properly test the material from the laboratories or the authorized testing centers.
Okay, sir. Okay.
So if these values are kept properly or what we say entered properly in the system, and whatever the values which ANSYS produces, if we have properly entered the values and the real-time data has been entered in it, the physical results are almost same. I guess 95% of the results are same which comes in the ANSYS. When we did the crash test of these stages which was in the system, it came exactly where the point should be. When the same values for the crash test was taken, the load, the speed, each and every value was taken as per the what is provided to the ANSYS, and what the results which ANSYS gave to us was the same result as the physical values. From the point where the ANSYS showed that this is the point where the chassis would break, it was the exact same point where the fracture or the crumple of the chassis happened. So if we try to enter the legit values or the real values, if we find for the material, then the results will be like very near to the actual value and the theoretical value. I can say not even 95%, even 98% the results were correct for the chassis, which we tested it based on the basis of this ANSYS stimulation and the physical crash test.
Hello. If anyone has any query, you can ask it right now, or else we will bind up the session. I request the team to share the feedback link in the chat box. If anyone has any query, you can unmute yourself and you can ask the question over here.
Hello.
So I would like to
So
tell you
one more
that, like,
doubt.
we are having. Yes, you can continue.
What else we can use as a material for this particular chassis?
See, there are three materials which I showed you. Other than that, you can go for AISI 1045, I guess, which is C45, which is 12. Then you can go for aluminum. Or else, if there are no constraints to you, or you are not going to any competition or any rule book category of competition where you have some constraint, you can use any material which you have. Square section, round tubular section, any material for tubular section you can use. You can go for steel, you can go for mild steel pipes, you can go for galvanized iron pipes. You can use any material.
So is it okay to use glass fiber and carbon fibers means?
Yes. Yes, carbon fiber is one of the best material for it. But we have some constraints. Due to this, we do not use carbon fiber. But if you are going for a legit formula event, or if you are going for an event which is based on the design constraints, that you need to provide the highest design constraint, you can use carbon fiber for it. See, glass fiber may not give you strength as much as carbon fiber, but glass fiber, you can make body panels or some component from glass fiber, but you cannot make a chassis from a glass fiber. If you are using glass fiber, then ultimately you need to add or sandwich something between the glass fiber, sheet or something, or else you need to roll that sheet heavily so that it can give you the desired amount of stiffness or it. But I don't think glass fiber is a good option for it. Yeah, definitely carbon fiber is best. But the carbon fiber we are not using, the reason is that there are so many small components which are to be attached on this. There are so many mountings which are to be attached on this. So if you are using metal chassis, if there are changes after the design or during the manufacturing period, you can easily attach or weld something on the steel pipes or aluminum. You can TIG weld, you can do TIG welding, you can arc weld something. If you want a small attachment or a small mounting to be added externally after the design was made or after the design procedure was completed, you can add it. But in carbon fiber, it takes a long time and you need to precisely check where the mountings are. On the basis of it, you have to make a mold of it, or you need to make an template of it. Then you can attach the mounting. And if something wrong goes with it, you need to remove the entire mounting. Right? So the machinability, or the working has some restraints with the carbon fiber. But if we are talking about the only underbody chassis or the piping, yes, we can definitely use carbon fiber for it.
Hello. Thank you everyone for joining this session. Now we are going to wind up the session. If you guys have any query or want to learn more about the go-kart designing and how to select the material and all, we have an internship course for you. You can join that course and we will deliver each and every part of this go-kart.
Brother, are there any essay related go-kart competitions any nearby?
I didn't get you, Shravan.
Are there any go-kart
Yes,
essay related competitions?
Yeah, we are organizing go-kart related competition. We have our Indian karting race that is being organized every year. And this year the event is going to happen in the month of October. So you can join that.
October. Okay, thank you.
Hello, sir.
So, yeah, Dhruv, please.
Sir, can we get the material that has been presented in this webinar or the recording for our future reference?
The recordings will be available for you. You will be getting the email and to download the certificate. So for downloading the certificate, you have to watch the video again, and then you can download the certificate on our portal. and that will be available on our portal. You just have to log in and sign up on our portal, and then you just have to go to your account and enroll in that course, and you can watch the video and you can download the certificate from there itself. So you will be getting the entire process on the email that is going to be shared within some time to your emails. You will be receiving that.
And one more query, sir.
Yes.
So can you tell more about the internship program that you have just mentioned?
Yeah, actually, we are going to deliver a 45 days internship program to all the students. That is going to be a live where we will be covering we will be starting from very basic about the go-kart to complete designing and as per the rule book of the events. So Shivam and the Saurabh will be the trainer, the same trainers over here. They will be the trainer for the entire internship program as well. So they will be giving you the live session on each and every aspect of the go-kart.
So how can we register for that?
So it is available on our portal. I will share you the link. I will share the QR code right now, and through that you can enroll you can share your queries or the inquiries through that, and then our team will get back to you. Just give me a minute. I will share that.
Thank you,
Yeah,
sir.
this was just the introductory webinar for that thing. But if you enroll the course or if you like to enroll it, each and every detail will be taught in the webinar or in this course, even with the calculation, each and every aspect, including the minor calculations of this thing will be added in this thing. And we will go with the basic theory to the manufacturing of the vehicle. This was just an introduction about the small component of a chassis. But we have each and every component which can be manufactured. So each and every component has their own individual calculations and all. And we'll be we'll be including all the calculations step by step in the course for this.
You guys can scan this QR code if you guys are interested in doing the internship. You can scan this QR code and fill up the inquiry form, and our representative will get back to you regarding the same. So if you guys have interest apart from the go-kart, you have the interest in designing the formula car or the solar car, we have the internship for those people as well. So if you are interested going for the internship in these domain, you can fill up the form and we will get back to you. You can share your interest to a counselor. They will counsel each and everything to you. So this QR code is only for those students, those who are interested in joining the internship program, not for the certificate download link and all these things. This is only for the inquiry.